Thank you, Greg. We'll have more time at the end that is reserved for question and answer, but if you have any urgent kind of a short question that you want to address to Greg at this point, shoot. Otherwise, we'll go just to our second speaker, and who is Anna Helmond, whose work has already been cited as mentioned, and Anna, like actually all of our panelists, is remarkable scholar in the sense that the thematic topics that we're talking about here, of course, but also the methodological innovations that are coming from that direction are really crucial and probably something we might want to talk about later in general as well. Anna is a PhD candidate as part of the Digital Methods Initiative, the New Media and Digital Culture PhD program, Department of Media Studies in Amsterdam. Her research, she's focused on platformization of the web, cross-syndication politics in social media, and data flows between web platforms. So her research interests around these areas: digital methods, software studies, platform studies, social media, web archives, etc. She's also worked, for instance, on the like button. Really fantastic work that was, again, yesterday mentioned. But today she'll be talking about something slightly different, I assume, and I think so. And thank you, Anna, it's all yours.
Thank you, Jussi, for this very kind introduction, and it's great to be back at Transmediale, this time as a participant, but I've been here before as a visitor and I absolutely enjoy it, so thanks. So what I would like to address today in relation to the topic of our panel are some ideas about the role of the underlying infrastructures and software architectures of the social web in both the creation, transmission, as well as transformation of data points. So I will take a more historical approach to this topic by tracing what I refer to as the platformization of the web, or the rise of the platform as the dominant infrastructural model of the social web. So within software engineering, software architectures are often discussed in terms of whether they're open systems or closed systems. And in relation to social network sites such as Facebook, they have often been conceptualized as closed systems using this metaphor of the walled garden. And this metaphor is then used to understand the architecture of social networks as closed systems, and also to critique them as such in terms of accessibility, inclusion, exclusion, and commodification. So the walled garden as a business strategy is based on a closed architecture to maintain control over both the systems as well as the users, and also enables the commodification of the users within this enclosed architecture. So social network sites have been characterized as walled gardens because they set up a particular set of technological barriers and technological walls, for example, for entering and leaving, and thereby also enforcing a particular type of lock-in, making it very difficult for users to leave. So, for example, walled gardens require you to log in with a password in order to be able to use its services. And there's very little access from the outside. In relation, all data inside of those platforms actually only exists as a data point in relation to another data point within that enclosed architecture. So for example, if you put a photo on Facebook, that photo does not have a public URL. So it's not publicly on the web and available. It's actually a link that demarcates a number within Facebook's database. So that means that it's only accessible for logged in Facebook users, and it also means that it's not part of the larger web. So this creates also critiques of that data gets locked into the systems, that they're creating data silos, and that it's very difficult for your to take your data out of those social networks and take it into another one, so the lack of data portability. In addition, they also present themselves as walled gardens because it's very hard for search engine crawlers to access them and to index them and to make them part of the larger web. So for example, Facebook only allows the indexing of particular public groups, but most of the content is blocked by search engines. So because they're also hard to index, they don't become, it's a second reason besides the fact that data is inside the platforms, they're not part of the larger web. So they're creating kind of data silos and thereby also seen as a threat to the open web. So Tim Berners-Lee, in his critique of those systems, is because they're not part of the larger web. So this architectural model of social network sites, however, I would like to argue, has changed over the years. And that this architectural model is now shifting towards this platform model. And for me, this also raises questions about whether this metaphor is still the right analytical tool to understand these platforms. So I would like to briefly go back to this idea of the platform, where social network sites are seen as typical Web 2.0 services. And this term Web 2.0, as Tiziana Cerenova yesterday also argued, is seen as this celebration of the web, as a participatory web, where users can generate content, and then shifting towards this model of monetizing that content. But it's really a piece of business jargon. It's a buzzword that's being used in different kind of contexts. But if we look at the original positioning of Web 2.0, it wasn't necessarily positioned as this celebration of the participatory web. Rather, Tim O'Reilly, who coined the term at the Web 2.0 conference, had in mind a very specific technological idea of the web as an operating system. So this is the announcement of the actual conference, where he calls Web 2.0 the web as platform. And here I would like to briefly explain what he means by that in order to position the idea of social media as platforms. So what he said is he actually positioned the web as Web 2.0 as a way to indicate that after the dot-com crash, there was this, he called it like a new web that brought about new business models, and there was once again an opportunity to monetize on the web. So he called that Web 2.0. And he contrasted it with what he called the old web. Of course, this is like a very interesting way to version the web to make all of a sudden we had Web 1.0, which didn't even exist before Tim O'Reilly positioned Web 2.0. But the thing is that he saw Web 1.0 as a system for publishing information. So really a publishing system that was based on the paradigm of pages. So websites have web pages. And he said Web 2.0 is actually the web becomes a development platform. It's no longer just a system for publishing information. No, it's a full development platform that we can build applications on, and deliver services. So this is, for him, this was a really technological model that enabled new kind of software services to run on the web. And this is also what we now know as this idea of like software as a service or the cloud, the web and the internet architecture at large becomes a full development platform. So what is this platform? What is a platform in a technical sense? And not in a metaphorical sense where something provides a platform for you to voice an opinion on. So a platform in computing is a system that can be reprogrammed. So it can enable other external parties to build something on top of it, and also thereby can anticipate new kinds of uses. So for O'Reilly, it was really this technical sense that the web is something you can build on top of. And this also creates a shift in what he called this idea of from web pages to web platforms. And the phrase the web as platform then refers to the fact that as websites start providing APIs, they are becoming a platform upon which other programs can build. So this means that the web becomes a computational platform, and it can also, so it's a recursive concept, can also be a platform for other platforms to build on. So the web as a platform But on top of it lies Facebook, which also offers APIs and can also become a platform for game developers to build their games on top of Facebook. So at the core of this idea of the shift from websites to web platforms is the idea of APIs, which enable this programmability of websites. So this is a technique that enables software developers to build something on top of your platform. And APIs kind of offer a software interface to a website. So if you go to Facebook, you have a user interface, something you encounter as a user with the stream and the profile. But Facebook also has a different side, a software interface that allows for developers to build applications on top of Facebook. So for example, I'm not sure if anyone here is an active user of Tinder, but Tinder as a dating app is built on top of the Facebook platform, and it uses your friendship connections and your likes to match you to potential partners. So Tinder here is an example of an application that uses Facebook as a platform. So what we see in the mid-2000s is that those social network sites are starting to offer these APIs, these software interfaces, which also turns them into platforms that other people can build on top of. And here you see a nice overview by the website Programmable Web, a kind of like a history of what I would say is the platformization of the web, or the rise of particular platforms as a new kind of architectural model that other developers can build on. So what I would like to put forward is that the API, this software interface to websites that makes websites programmable, have turned social network sites into social media platforms. And that this architectural model of the platform, as also in the work of Ganaele and Greg, operates on its own logic that deserves very close attention. So what follows in the second part of my presentation is a detailed material technical perspective on the development and emergence of what we now understand as platforms by further developing this notion of platformization. And I do so by addressing three elements of platformization that have historically enabled the programmability of websites through the exchange of data, content, and functionality with third parties. And this historical approach to website data exchanges with third parties shows how social media platforms have enabled their extension into the web, and in doing so are making external web data platform ready. So it's about this proliferation of data points, but also the transformation of data points. So let me start with the first element, which is the separation of content and design. So if you go to the early days of the web, when websites were made in HTML, HTML is like a markup language that doesn't neatly distinguish between the content and the content and design of a website. So it's very hard to for other programs to extract data from websites and reuse that in a different context. So in order to build something on top of something else, we need to take those two apart and separate the content from the design in order to make data transmissible. So this was enabled by a technique called XML, which separates the content from the design. You can see here in the example that it's like a very structured way to mark up a page. And what this actually enables is it makes websites machine readable. And it also enables content to then circulate, because machines can say, give me the title of this CD. And they can just get it from that file. That wasn't possible before, so this made it possible for data exchanges on the web to happen. So according to scholar Alan Liu, this separation of content and presentation informs the underlying technologic of the post-industrial transmission of information. And he says this requires content to be made autonomously mobile and automated. So enable, this mechanism enables these automated data exchanges. And this separation Lou continues, makes content transcendental, so that it can be moved from database to database and from container to container on particular websites. So this separation of content and presentation and pouring data from container to container is what we now see in so-called widgets. And here I took like one of the first widgets ever created by in the context of the web by YouTube, where they actually made it possible for users to put their own videos on their own websites. This now sounds like, you know, not such a very innovative idea, but it was very innovative in the sense that it made it possible to reuse content from one website to the next. And here you can see that data from YouTube's database can be poured into an external website. So they're like very small applications that can be embedded in an external source that can move data from and to different databases. What we see here is an example of a very early widget which only enables one-way data flows. So these can only pull data out of the database of YouTube. And a next generation would enable two-way data flows by also putting data back into the database. So this is then what Alan Liu calls these data pours, these snippets of code that you can put on a website that then creates these data pours for the videos of YouTube to flow in. So here you can see specified that you insert a particular username and it gets all the videos from that user. So these were the one-way data flow widgets, I would say. While the more modern widgets, for example, the like button, but also like the Facebook comment system, they enable what I would say two-way data flows. They also allow new data to be put back into the database. So for example, if I first this container of the like button loads the information from Facebook, for example, the number of likes it has, but also which of my friends have liked this page. But then once I press the button, it can also send data back. And what this did was create a direct connection that can interface with those databases in two ways. So what these systems have done that are now in place is what I call the dual logic of platformization. So what this has enabled is the extension of social media platform features into the web. But at the same time, I would like to argue the data that is now being put back into those databases is specifically made platform ready. And I will explain what I mean with that. So instead of just putting data back and forth, I would like to say that the data that is putting back in those databases is specifically formatted for the purposes of the platform. So it follows the logic of, for example, Facebook's agenda. So how is this done? There are a number of different mechanisms that are being put in place that make external web data ready for those platforms. And here the developer pages of those platforms provide a very rich source to analyze what kind of systems are in place to make external data platform ready. So one I would like to address is Facebook's software development kit, which allows webmasters but also app developers to integrate their websites and apps into the Facebook platform. So for example, Tinder. It uses this software development kit to open up data channels between the Tinder app and the Facebook platform. And it makes, in doing so, it formats the data, especially for the platform of Facebook. So it can be read by Facebook, processed by Facebook, and then further transmitted to partners and advertisers. So if you want to integrate with Facebook or use any kind of functionality of their platform, which just includes if you want to insert a simple like button, you already have to insert a piece of code that creates, as part of this development kit, which creates data channels between your website and Facebook. So in order to do anything with Facebook, you have to set up these data channels. Another important part of Facebook's larger platform is what they call the open graph. And this is explicitly geared towards making external data platform ready. So this open graph enables third parties such as webmasters and app developers to integrate their websites and apps into Facebook. But in order to do so, they give you a very detailed manual about how to do this, how to integrate with Facebook, because it needs to be in a very structured manner. And one of the most recent mechanisms here, and which I also connects back to Greg's point that data points need storytelling, this is explicitly what Facebook calls telling stories. So Facebook wants you to tell stories using particular data points. So let me first pull up this graph. So in order to use the functionality of Facebook, for example, in your app, you need to tell the Facebook platform what your data point is and how it's connected to a particular user, and also what kind of action or relation it specifies. So what it wants you to do is structure your information according to 4 elements. You have an actor, you have an app, you have an action, and you have an object. And that's what you see here in this graph. So for example, you can see here, you could say, John, who's an actor, is reading, and then the title of a particular book, on the app of Goodreads, an app to read your information. And this is also what Jussi said. It's also about this idea of, it's for them, it's also an artificial intelligence challenge. It's also, one could also say they're building a different version of the semantic web, but that's another discussion. But they want you to format the data according to their logic so it can be integrated into their larger system. And this is not particular to Facebook only. This is done by many different kind of social media platforms. So for example, Twitter uses something called cards, where they also ask you to specifically format your website so Twitter can read it. And when I say Twitter can read it, I mean making it ready so that the data points can also enter specific algorithmic calculations within the Twitter platform. So unlike the business strategy of social networks to commodify user content and activities within their walled gardens by pulling users and content in, I would say the business strategy of platforms is phased outwards to extend themselves into the rest of the web and app spaces and make those data points valuable for their platforms. So this web as platform or programmable web with its social media platforms, I would say is very different than from the walled gardens. Because we're no longer talking about like small openings, pores, but we're talking about continuous data pores where content is being flooded from one place into another. And then that flooded information is made ready for those platforms. So the examples I've show how social media platforms enact a very different architectural model than social network sites. Social media platforms are seen as being geared towards their extension into the web and into external apps. And in doing so, they are making external data ready to enter the platform and then for further processing within this platform. And in doing so, I would like to end, they are making the web more and more into social media. Thank you.
Thank you, that's great. Any really quick questions that you want to address now? There's one there, back there. Do we have a mic if we can take one really brief question? Because then we have more time in the end, but please.
Yeah, so I was wondering, like when you make an application for Facebook, for instance, to make your photos more anonymous, Facebook is actually known to take down such applications. And Twitter also discontinued their 1.0 API, also disabling a lot of applications and programmers' work just in the trash bin. How do you feel about the platform being open in such a light? how do these relate?
Yeah. So this open-closed dichotomy, I would say it's rather positioned on a continuum. So it's not either open or closed, because I would say it's a continuum. And on top of that, one could say it's technologically open, but that doesn't mean that there are very tight restrictions. Also because, for example, to use the platform, you must register with them as a developer. You get like a specific key that gives you access to the data. And that key can also be connected to very particular restrictions. So, for example, if I would be a paying developer of a large company, I could get more access to data than, for example, a free developer. So, yeah, when we're talking about open and closed systems, authors such as Jonathan Zittrain also say that they're constantly operating on being open and closed, and finding also their way in relation to those third-party developers. And what we've seen, for example, with Twitter, that it used to be a radically open platform, inviting developers, but they are continuously like shutting down by restricting the kind of applications you can build on top of them. So I would say that in terms of open and closed, we should add this extra layer indeed of kind of the API becomes a controlling mechanisms in relation to those developer. And yeah, in relation to that, I would also recommend the work of Taina Bucher on APIs as like protological regime machines. So yeah.
Very good, thank you. Let's go to our second speaker, or do you have a really quick question?
Well,
okay.
What you just said to me makes me think about the old mainframes. Did you look at the old types of computing that was before the kind of web, and how does that relate to the platformization of the web, which to me sounds like the old mainframe years?
Yeah. No, absolutely. If you, for example, think of the IBM 360 system, that used to be a closed system because it integrated hardware and software into one, allowing only IBM to make that software. But because that was seen as an anti-competitive practice, they were forced to disentangle that, which actually led to the creation of the whole software industry. So that's a good thing. But indeed, yeah, there are relations between those open and closed systems that go way back into like old architectural models of computing. Yes, definitely.
Very good. That's a good point.